In this video, I will go over the homework that follows the lecture 6.3, focusing on L'Hopital's rule, using the L'Hopital's rule, resolving an indeterminate form involving powers. So, as always, I hope you watch the lecture, and let's get started. Here's the first problem. And we have a limit as x approaches to infinity. And the first thing we want to do is we want to plug in infinity in, and we want to figure out the type. So 9 over infinity is 0, 1 plus 0 is 1, and 4 to the power 4 times infinity is infinity, so we have 1 to the power infinity, which is one of the 7 indeterminate forms. So the way I like to do this type of problems is I like to set this to L, and now the question is simple. We need to find L, but instead of finding L, we will be looking for ln of L. So ln of L will be ln of this limit, but since natural logarithm is a continuous function, we can pass it through the limit, or we can pass the limit through the function, and here's what we have. Now, using the properties of logs, we can bring this exponent out. And what did we achieve with all these transformations? Is the type of the limit now has changed. So now we have infinity times 0. And we're going to resolve this indeterminate form by rewriting it as a ratio. So we're going to keep ln in the numerator, and we're gonna input 1 over x in the denominator. So now the type of the limit is 0 over 0, and now we can use the L'Hopital's rule. So according to the L'Hopital's rule, the limit will be the ratio. So in the denominator we have -1 over x squared, and in the numerator we have 4 times, and we have reciprocal of 1 plus 9 over x times the derivative of 1 plus 9 over x, which is -9 over x squared. Now x squared is out, minus is out, and we have and there is no minus here, this is plus, so derivative of 1 plus 9 over x squared is, oh no, there is minus there. And what do we have here? We have -36. So, but remember, -36 is just ln of L. So if you want to find L, then we have to exponentiate both sides. So L is e to the power -36. So hopefully I didn't make any typos. So let's try entering e to the power -36. Oh, why negative? Oh my god. So it's positive. And that's how we resolve this type of indeterminate forms that contain powers. Let's try another example. We have a limit as x approaches to 0 of 1 over 5x to the power 1 over 5 ln 7x. So what type of limit this is? It's infinity to the power 0. And we're going to set it equal to L. Now we're going to find ln of L. And we're going to pass the limit through the ln right away. So we have limit as x approaches to 0 of, and I'm going to write the exponent out of the logarithm right away, times ln of 1 over 5x. So this is interesting actually. So we have what we have now is actually, well, technically it's 0 times infinity, but it's already written as a ratio, so we're just gonna regroup. So we have ln of 1 over 5x divided by 5 ln 7x, and this is infinity over infinity, meaning now we can use the L'Hopital's rule. So according to the L'Hopital's rule, the limit is the ratio of the derivatives. So derivative of ln is reciprocal of and I guess here we can, to make it easier to differentiate, here's what we can do. Instead of 1 over 5x, we can write it as 5x to the power negative 1, and then 1 can just, the power negative 1 can just go outside. And now this is easy to differentiate, right? So we have negative 1 over 5x times 5, and here we have 5 times 1 over 7x times 7. X is gone, 7's gone, 5's gone. So the final answer is negative 1/5. And remember, this is ln of L. L is equal to e to the power negative 1/5. All right, let's try another problem. We have limit x approaches to 0 plus cosine at 0 is roughly 1. 1 over 0 is infinity, so we have 1 to the power infinity. Let's call this L. Let's focus on finding ln of L. It will be the limit of x approaching to 0. We're going to pass the limit through ln, and we're going to use the properties of ln and bring the exponent outside of the logarithm. And now what do we have? We have a product of infinity, and ln of 1 is 0. So we're going to rewrite this as a ratio. Now the type of the limit is 0 over 0. And now we can use the L'Hopital's rule. So according to the L'Hopital's rule, we differentiate. In the denominator we have 10x. In the numerator we have reciprocal of cosine of 6x times the derivative of cosine, which is negative sine 6x times times 6. And it makes sense to rewrite this limit. So we have negative 6 tangent 6x divided by 10x, and it's 0 over 0. So that means we can use L'Hopital's rule again. And when we use it again, what's the derivative of tangent? It's secant squared, and by the chain will be multiplied by the derivative of 6x, which is 6. And in the denominator we have just 10. So now secant of 0 is 1. So the answer is negative 36 over 10, or negative 3.6. So remember, this is just ln of L. L would be equal to e to the power negative 3.6. All right. Another L'Hopital's rule application. After plugging in 0, we see that we have 1 to the power infinity. So we're going to set it equal to L. We're going to find ln of L. ln of L will be limit as x approaches to 0. We're going to bring the exponent down. And now we're going to rewrite it. Right now it's infinity to the power 0. So we're going to rewrite it as a ratio. And now we have 0 over 0. So we can use the L'Hopital's rule. And according to the L'Hopital's rule, we just differentiate the numerator and the denominator. So in the denominator we have 9. In the numerator we have reciprocal of this function times the derivative of this function. So it's going to be 6e to the 6x plus 2. Now plugging in 0, what do we have? We have 1. Here we have 1 plus 0 times 6. E to the 0 is just 1 plus 2, all divided by 9. So it looks like the final answer is 8 over 9. But this is ln of L. If ln of L is 8 ninths, then L is e to the power 8 ninths. And we finished this homework. If you have questions about using the L'Hopital's rule to resolve indeterminate forms that contain powers, then please let me know.